Hello everyone, welcome back in the series of insertion operation on a linked list data structure. Today we are going to see how to insert a node before a target element in a linked list data structure. In the previous video we saw how to insert a new item after a given item in a linked list data structure. Suppose the user want to insert a number before number 40. This time again our algorithm is going to accept two values. One, the target value before which we want to insert the new item. Say the user want to insert before number 40 in the list, and also a data or new data. Say the user want to insert 100 before 40. As usual, we are going to create a new node having the new data. Say in this case this new node's data is going to hold 100, and this new node's I'm gonna call it new node, and this new node's next pointer is initially going to point to null. Imagine this new node having memory address 500. So in the previous video we saw if we get a pointer to the target node using this pointer, say temp pointer, we could easily insert a new node after this temp pointer. But this video we are going to see how to insert the new node before the temp pointer or the target node. To do that we need another pointer which points before the target node or the temp node. So we are this time going to maintain two pointers, one temp pointer and another, let's call it previous pointer or prev. Once we got a previous pointer to this node, to the previous node of the target node, then using this pointer, as we saw in the previous video, we can easily insert a node at this location. So what I'm gonna do is, instead of maintaining one pointer, this time when I traverse over the linked list, I'm going to maintain two pointers. One, let's call it previous pointer or prev. Initially this previous pointer is going to point to null. Then I'm gonna maintain a current pointer or temp pointer. I'm gonna call it temp, but most of people call it current, CUR, or current pointer, that indicates the current node. So I'm gonna use temp to traverse over the linked list. Initially this temp pointer is going to point to head. Okay, temp is pointing here. As I traverse over the linked list, I will move the temp pointer, but before I move or update the temp pointer, I will have the previous pointer point to the temp pointer, then I will have the temp pointer point to the next node. In the next round of loop, before updating the temp pointer, I will have again the previous pointer point to the temp, then I will update the temp pointer and move the temp pointer to the right. This way I can maintain two pointers. One pointer is pointing to the previous node and one pointer pointing to the current node or temp, let's call it temp pointer. The next round of the loop, before I update the temp pointer, temp is pointing here, I will have previous pointer point to the temp pointer, then I will update the temp pointer to the next node. If I got the target node, I have a previous pointer and I have a current pointer. So using this previous pointer I can easily insert a node to this location. So let's write the code for this. Let's first define two pointers. I'm gonna call it node previous pointer. Initially it's going to point to null, and then let's maintain another pointer for traversing over the linked list. I'm going to call it temp. You guys can call it current pointer. Initially the temp pointer is going to point to head or initial node of the linked list. Then using a while loop I keep traversing over the linked list and I check until I haven't reached end of the linked list or I haven't found the target node. I keep moving. I update the temp pointer and the previous pointer. So using a while loop I say while temp not equal to null until I haven't reached end of the linked list, and at the same time I check and temp dot data is not equal to target. Until I haven't found the target or haven't reached end of the linked list, I keep looping. So before I update the temp pointer, as I said, I will have the previous pointer point to the temp, previous equal to temp, then I will update the temp pointer, temp pointer equal to temp dot next. I'm using the AND operator here. Both the expressions should return true in order to for the overall expression to return true. If any of these expressions return false, the overall expression will return false also, and we will exit out of the loop. So Let's check if temp while temp is not null. Initially temp is pointing here at the head node. Temp stores memory address 600. Temp is not null. Yes, temp is not null. This condition is true. And temp.data is not equal to target. Temp.data, which is 10. 10 is not equal to 40. The condition is true. We go in inside the while loop. I will have the previous node point to the temp. So right now previous and temp both pointing to the head. Previous also hold memory address 600. Then using this expression I move the temp pointer to the next node. Temp equal to temp.next. Temp.next is storing memory address 100. So temp is going to point to this memory address, or temp is going to hold memory address 100. Then I will again check if temp is not equal to null. Temp is not equal to null. Temp stores memory address 100. Temp.data is not equal to target. Yes, temp.data, which is 20, is not equal to 40. The condition is true. Before updating the temp, I'm going to have the previous pointer point to this node, to the temp node. Then I will update the temp pointer. So this time temp pointer is going to point to memory address 45. And the next round of loop, I'll again check the temp pointer. The condition is true. So I will have the previous pointer. Let me clear all these. So right now temp pointer is pointing here. Temp pointer is pointing here. Before updating the temp pointer, I will make previous pointer point to the temp. Previous equal to temp. So previous pointer is going to come here. Then I will update the temp pointer. I will have temp equal to temp.next. Temp.next stores memory address 900, which is this node. So temp comes here. Temp comes here. Then I will again check if while temp is not equal to null. Temp is not equal to null. Yes, because temp is storing memory address 900. And I will check if temp.data is not equal to target. Temp.data, which is 40. 40 not equal to target. Yes, 40 is equal to target. The condition is false. So we exit out of the loop. So using this previous pointer, we can easily insert the new node at this location, which is before the target node. Okay, we saw it in the previous video. First, we will have the new node.next point to this memory address. Then we will have the previous .next to point to new node. Or either we can first, since we have two pointers, if we set in the previous video we saw if we set previous .next, we will lose this pointer. Previous .next equal to new node. So this is going to store memory 500, and we will lose this this connection. But this time we have a temp pointer which is pointing to the rest of the linked list. So we are not going to lose connection. Again, we are going to set new node.next equal to temp node, and this way we can establish the connection. So let's do that. First, we are going to establish this connection. We will say previous. To insert the new node, we will say previous prev.next equal to new node. So prev.next is equal to new node. This connection will be established. Prev.next is going to store memory address 500, which is the memory address of new node. Then using the temp pointer, we can establish or create this connection, okay, by saying new node.next equal to temp. New node.next equal to temp. So new node.next is going to store the memory address of temp. Temp right now it stores 900, so instead of null we are going to have 900 here, and this is going to point here, and we have the linked list. So right now temp is pointing here and previous is pointing here. So but before we insert the node here, we are going to check if temp not equal to null. We're going to check if we haven't reached end of the linked list, then we will insert. Else, if temp is equal to the null, means we have reached end of the linked list and we didn't find the target value, then we are going to, in the else part, we are going to prompt the user we didn't find the target value. With this algorithm, there are two edge cases to take care of before inserting the link in the linked list. First, we are going to check if the linked list is empty. If the linked list is empty, we're gonna return and we don't do anything. We just prompt the user the list is empty. We cannot insert before this item. Also, if the user want to insert before the head node or before the first element, we don't have a previous node here, or we cannot maintain a previous pointer here. In that case, we are going to just call our insert at the beginning function. We can insert the new node here at the beginning of the linked list. So we gotta first take care of these two corner cases, then we are going to implement our algorithm. So let's jump into IDE and write the code for inserting an item before a target value in the linked list. So I'm gonna go to my linked list, insert after this function. I'm going to create a new function. Let's call it public void insert before. This is going to take a data and also end target. So first we are going to check if the linked list is empty. If is empty, or if head is equal to null, we just want to prompt the user the linked list is empty. We just return, and we don't want to do anything. Return. This is a function. We gotta put the parentheses here. We also going to check if the user want to insert at the beginning, before the beginning of the linked list, before the head. So we check if head dot data is equal to target. Then we just call our insert at the beginning function, and we pass the data, and we just return. We are done. Else we will maintain two pointers. Node previous pointer is going to initially point to null. Then we are going to maintain a temp pointer, node temp or current pointer. Initially this is going to point to head, and we check while we haven't reached end of the linked list, while temp not equal to null, and we haven't found the target node in the temps.data, while temp.data not equal to target. We keep moving. Before we update the temp variable, we are going to have the previous pointer point to the temp. Then we will move the temp pointer to the right. So we say prev is equal to temp. Then let's move the temp pointer by saying temp equal to temp.next. Once we either found the target data, and or either we reach end of the linked list, we exit out of this while loop. We again gonna check if temp equal to null. If temp is equal to null, means we reach end of the linked list. We are going to just prompt the user item not found. Else we are going to insert the item by saying previous.next equal to new node. We haven't created new node, so first we are going to create a new node. New node equal to new node, we pass the data. So previous.next is going to equal to the new node. Then we say new node.next equal to the temp, or prev. Okay, we don't have prev.next because we will lose the connection, so we are going to use the temp pointer. So this way we can insert an item before a target value in a linked list. Once we inserted the item, we are going to increment our length variable, or the size of the linked list. So let's check this function. I'm going to go to the main function. So I have 10, 20, 30, 40, 50. Say I want to insert a new item before this 40. So list dot insert before. The spelling is wrong, we can fix that. Let's insert 100 before 40. I could easily insert it 100 before 40. Say I want to insert it before 50, or the last element. Okay, I got 100 before 50. Say I want to insert it before the first element. So 100 is going to become the head element. Okay. So let me rename this function. Okay. Rename insert before. Awesome. say I want to insert before number 20. Awesome. So this way we can insert an item before a target element in a linked list. Thank you guys for watching. Please don't forget to subscribe to Code with Cougar, and see you in the next video. Bye bye.